Montana Digital Academy Algebra 2 class. One of the requirements for this class is to have a trigonometry assignment, and our material doesn't have that in it, so I prepared stuff, or as I thought about how to prepare stuff, I asked my pre-calculus class to help me with this. So in the coming videos, they're going to be presenting several lessons that deal with the Algebra 2 topics that are typically taught in a high school Algebra 2 class, or the trigonometry topics that are typically taught in an Algebra 2 class in high school. So I'm going to just run through this and introduce a few things that we'll be looking at as we look through this material. I used a program called Prezi to create a presentation here. Trigonometry comes from the Greek word meaning triangle measure. Usually begins by examining the sides and relationship between the sides and angles in a right triangle, much like you looked at in geometry. One of the first lessons we'll be looking at is some right triangle trigonometry. We'll introduce you to the definitions of sine, cosine, and tangent. And someone will talk about something called SOHCAHTOA, if you haven't heard of that before, how to remember those relationships. The next lesson we'll be looking at is angles of rotation and how to look at angles in a unit circle on a coordinate system. And we typically look at points x and y and measure left and right and up and down, but we'll also look at angles of rotation, how that fits in with a trig topic. Third thing we'll look at is the unit circle. We'll change that definition of sine and cosine a little bit, and we'll get them to fit on this on a coordinate system. And we'll look at the definitions of sine and cosine and how that plays out in trigonometry. The fourth lesson that we'll be looking at is the inverses of trig functions. One of the things I always like to say is once you learn how to do something forwards in a math class, it isn't going to be very long before you have to work on it backwards. So we'll undo the stuff that you've been doing and do the inverses of those. The next lesson is probably a couple of the favorites, the law of sines. We'll look at a relationship that happens in any triangle. Most of the stuff we'll have looked at in the first several lessons will be with right triangles. Law of sines takes those applications that you've learned and applies them to any triangle. So we'll be looking at law of sines, and the next lesson is the law of cosines. There's two formulas in there that you have to be memorized, and students find that they use those sometimes more than they actually use the right triangle formulas. So that's mostly algebra work, and we'll be looking at that in some of these lessons. And of course, you have to graph them, graphing sine and cosine. That's going to be a fairly easy lesson as you look at those graphs, how they come out of the unit circle. And then we'll look at a little more complicated things in the graphs of some other functions. The next slide there, guys. Thank you. Some other trig graphs. We'll look at the graph of tangent, the graph of the inverse function, secant, cosecant, and cotangent, and what they look like. One of the things that the class will be asked to do is to create some homework for you. So we'll probably send that to you some way and ask you to send it back, either fax it or scan it back to me. So it'll be a little bit more traditional type homework lessons on paper and stuff. I'm not going to try and create anything from Moodle and try and get that to you in that form. So you'll have to have a series of problems to solve for us. And of course, there'll be a test. I'm not sure we'll have any quizzes. There'll probably be something at the end of the chapter test, and we'll have a quiz sometime halfway through the material here. We'll put something together and see what we can do for you. So there's 11 students in my pre-calculus class, and they'll be working on. Go ahead and move that one up. They'll be working on putting this material together for you. So we'll see how it plays out. It's kind of a project where we doing some fun things, and a good break for them as they try and figure out how to put this together. And they'll introduce themselves to you later as they work through the lessons. So looking forward to doing this. I want to mention a couple things about this material before we go on here. If you take a square and you do half of it, you get a 45, 45, 90 triangle. And you all know that these sides are equal here. One of the main ideas in trigonometry is what's the relationship between this opposite side and this adjacent side? Well, in this particular triangle, they're always equal. You always know that, and no matter what 45, 45, 90 triangle I draw, they're always going to be the same. And that relationship between this side and this side is always the same. Most of you know that if this side here is 1, this side here is 1, that this side is the square root of 2. And one of the key ideas for trigonometry is in this kind of triangle, that relationship is always the same. And that'll play out through all these problems as we work through them. Another special triangle that's worth mentioning at the very beginning here is half of an equilateral triangle. If you take an equilateral triangle, You do half of it, you get what's called a 30-60-90 triangle. And there's a relationship between these two sides also. This one's easy. This side here is 2. Okay, then I said it was equilateral, so that side is 2 and that side is 2. This distance here of this 30-60-90 triangle has to be a 1. And then you apply the Pythagorean theorem to this, you'll discover, and you can prove, that this side here is always the square root of 3 times this side here. Well, the trig application is this really ratio is always a half. This ratio is always the square root of 3 to 1. This ratio here is always 2 to the square root of 3. And we'll look at tables and they teach the unit circle. You'll see some of these relationships come up, because these actually are the ones when you do a class beyond this that you actually have to memorize and do a lot of things with them as you study the unit circle and other trigonometry classes. So that happens. Another thing that I want to mention is dealing with some geometry ideas. Remember similar triangles in geometry? Okay, remember similar triangles? That any triangle has 3 angles equal to each other. Those triangles are similar, and the key thing with that is that their sides are proportional. And that's going to show up time and time again in this lesson, the proportionality of the sides. There was another one here with this one I'll mention it. We won't talk about it very much, but the side angle side relationship. And also remember in if you had congruent triangles, we had 5 of those. We've been teaching in my geometry class lately. They're side, 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 angle, side, angle, side, angle, 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 side. And the last one is this, and there's a lot of things that we can look at with that, and some of that will show up as we look at the law of sines. The law of sines says this. Some of those people are going to be teaching that, and it says this. If I draw a triangle, and this side here is 10 miles, maybe miles, and this angle here is 15 degrees, and I have this side, this angle over here is 20 degrees, all of the sides of that triangle are determined. All the rest of this is determined. If I have an angle-side-angle relationship here, all these sides can also be calculated. And those are some of the things that we'll be looking at in this chapter. So hopefully this will they're all being very, very quiet. They're never this quiet. I got the whole class out here right now. So hopefully this will be a good lesson, and we'll have a lot of fun with it. That's going to be one of our main goals, is to have fun with this and teach you guys some of the trig topics that you'll need to have as you finish up this Algebra 2 course. Okay? See you in another lesson, and I'm sure we'll show up someplace else. So, all right, thank you.